Hi, my name is Ameen Zafiruddin and I'm a first year student here at UNC Chapel Hill. And in this video, I'm going to be talking about calorimetry for the Quantitative Chemistry Lab I. So calorimetry is used to measure the amount of thermal energy transferred during a chemical or physical process or reaction. And this requires precise measurements of the temperature change that occurs during that process and of the masses involved. And these masses fall into two categories: the system and the surroundings. The system is the substance or substances undergoing chemical or physical change. The surroundings are the other components of the measurement apparatus that serves to either provide heat to the system or absorb heat from the system. Reactions or processes which release heat from the system to the surroundings are exothermic, while reactions or processes which absorb heat into the system from the surroundings are endothermic. Now that we know what calorimetry is, how do we actually measure the transfers of heat between the system and the surroundings? That is where a calorimeter comes into play. A calorimeter is a device used to measure the heat involved in a system or process. And there are many different types of calorimeters used by different individuals for different processes, but as a student of Quantitative Chemistry Lab I, you're going to be building and using your own coffee cup calorimeter. This consists of two styrofoam coffee cups, a cup lid, a stir bar or stir stick, and a thermometer. In the case of experiment 2 and 6 of this lab, this device will measure the heat transferred from two substances reacting in a water solution. For these experiments, the water is the surroundings, while the substances which are reacting are the system. There are lots of different uses for calorimetry and a calorimeter. This includes measuring the amount of heat transferred between substances of different temperatures, or identifying a metal using its specific heat, or in the case of our experiments 2 and 6, measuring the amount of heat produced or absorbed by an endothermic or exothermic reaction. And for all these uses, measurements taken throughout the process using the thermometer can then be used to compute the heat transferred using known mathematical relations that we know listed here. Keep in mind that Q stands for heat, while the subscript describes what the heat is of. M is the mass of the substance, C is the specific heat, and delta T is the change in temperature. As you could probably guess, styrofoam cups aren't the perfect insulators, and heat transfer to the water could seep out of the calorimeter. Scientists use well-insulated calorimeters made with professional materials to get the best results, but there's a way for us students to account for this in lab. This is known as a calorimeter constant, and you'll learn how to calculate this yourself in experiment 6 of this lab. Every calorimeter has a different calorimeter constant and can be used in equations to compensate for any heat loss in a reaction or process we observe. Interestingly, there's a special type of calorimeter known as a bomb calorimeter. These calorimeters are used to measure the energy produced by a reaction that yields large amounts of heat or gaseous product, such as a combustion reaction. One of the most important uses of these calorimeters is for measuring calories in food. A calorie is exactly 4.184 joules, and a kcal, commonly used outside of the US, is 1,000 calories and is the exact amount of energy needed to heat 1 kilogram of water by 1 degree Celsius. Foods are weighed, mixed in a blender, freeze-dried, grounded into a powder, and then finally formed into a pellet. This pellet is then placed into a bomb calorimeter where it's ignited and measured. Yeah, those facts aside, bomb calorimetry and measuring nutritional calories are outside the scope of Quantitative Chemistry Lab I, so you don't need to worry about them for this lab. Oh, okay, got it. That was just a joke, but thank you all for watching. That was my overview of calorimetry and how it applies to this lab. If you want to learn more, feel free to read the lab manuals for experiments 2 and 6, which are aqueous reactions and thermochemistry respectively. So yeah, you'll learn more there. You can also just search up online and learn from there. But yeah, thank you all for watching.